Hi guys, in this video we will learn the rules of radicals. So let's start with the first one, that is rule 1. So it reads root of a all squared is equals to a. Now whenever you have this, always use this to cancel this. Okay, so as for root 9 all squared, this we cancel this and we are left with 9, right? So if you like, you can still start from what we have inside the bracket, simplify before you now distribute the square over it. This is what I'm trying to say. For instance, you have root 9 all squared. So if this one can work, you always do 3 squared, and that's we give 9. So in a case whereby you have 5, okay, 5 squared, so there is no way you can take the square root of 5 to get a whole number. So what you just do is this, cancel this, and you are left with 5. Then for root 2, we have root a times root b is equal to root a times b. Yeah, so this is example here. Root 9 multiplied by root 16 is equal to square root of 9 times 16, and this is 144, and this will give 12. Alternatively, you can do it this way: root 9 multiplied by root 16 is equal to the square root of 9 is 3 times square root of 16 is 4, and this will give us 12. So anytime there is multiplication, just take the common roots and put the numbers inside the roots. Then for rule number 3, we have root a divided by root b is equal to root a over b. So an example is given here: root of 16 divided by root of 9. This is equal to root of 16 over 9 is equal to 4 over 3. So if you decide to solve this differently, you still get 4 over 3, as is root 16 divided by root 9. This will give 4 divided by 3, and that is 4 over 3. Okay, now there are some cases whereby you can't solve directly. For instance, let's say we have root 3 divided by root 7. Okay, you know that this is something as root 3 over 7, right? So you can equally put it this way: 3 over 7 all to the power of 1 over 2. Okay, so that is it for root 3. Now for the next one, root 4, we have x root a divided by x root b. This is same thing as x root a over b. So for instance, here we have cube root of 27 divided by cube root of 8. This will give us cube root of 27 over 8. Yeah, so if you decide to solve it separately, this will give us cube root of 27 is 3, and cube root of 8 is 2. Okay, so let's go to the next one. So for rule number 5, when you have a combination like this, this is a common factor, this root a is a common factor, so you can always factorize by bringing out a and put in b plus c inside the bracket. So this is same thing as b plus c, okay, root a. Now let's look at this example. Imagine a situation where we have 3 root 5 plus 2 root 5. Okay, this is common factor here. We bring out root 5, then 3 plus 2, and this is same thing as 3 plus 2. Okay, root 5, this is 3 plus 2 is 5, and we get 5 root 5. Then for root 6, we have b root a minus c root a. The common factor here is root a, so just put root a here. Okay, then b minus c. Yeah, you put b minus c, b minus c. Okay, root a. Example, let's say we have 7 root 3 minus 4 root 3. Okay, the common factor here is root 3, so bring out root 3, then 7 minus 4, right? So this is something as root 3 multiplied by 3, so this is 3 root 3. Okay, then for the next one, root 7. Anytime you have b over root a, this is always written as b root a over a. Now it is not normal to write square root sign as denominator. So in order to simplify this root a is always rationalized. That is to say, this fraction here is rationalized. And how can we rationalize this? When we have b over root a, all you just need to do is multiply by root a over root a. Now don't forget, this root a over root a is same thing as 1. Okay, so multiplying by root a over root a doesn't change any results. The results still remain the same. So if you check, root a divided by root a is 1. Okay, so now we multiply, this becomes b times root a divided by root a. Root a times root a is root a squared, so this will cancel this, and this will give us b root a divided by a as what we have here. Now let's take one example here. For instance, we have this simplify 10 over root 2. Okay, so what we just need to do is to rationalize this, and that will give us 10 over root 2 times root 2 divided by root 2, right? So this is 10 times root 2 divided by root 2 times root 2. So this is 10 root 2 divided by root 2 times root 2 is 2. So we can cancel here, 2 here 1, 2 here 5, and this will give us 5 root 2. Okay, then for root 8, we have this root of a plus 1 divided by root of a minus 1. Now this one is a little bit tricky. Whenever you have this as the denominator, use its conjugate to rationalize, okay, the way we did here. So the conjugate of root a minus 1 is root a plus 1. So we use this as the conjugate of this to multiply the numerator and the denominator. Now when you have here, like the one we have here, if it was root a plus 1, then the conjugate would be root a minus 1. So to rationalize, in this case, use like the opposite of this. If here is plus, then it puts minus here. If here is minus, then it puts plus here. So let's take one example on this root 8. So imagine you're asked to simplify 4 upon root 5 plus root 3. Okay, so we rationalize by using the conjugate of root 5 plus root 3. So the conjugate, okay, conjugate of root 5 plus root 3 is equal to root 5 minus root 3. So we'll use root 5 minus root 3 to rationalize this radical problem. So this will now become 4 divided by root 5 plus root 3 times root 5 minus root 3 divided by root 5 minus root 3. This will give us 4 root 5 minus root 3, right, divided by, now if you see this multiplied by this, it is difference of 2 squared, so that will give us root 5 squared minus root 3 squared. So we now have 4 open brackets root 5 minus root 2 divided by this one will become 5 minus root of 3 all squared is 3. Okay, so we'll solve this further. It gives us 4, okay, root 5 minus root 2 all over 2. This can always cancel this, and our final answer becomes 2 open bracket root 5 minus root 2. Right, then for root for root 9 and 10, for root 9 and root 10, please always note that root of a plus root of b is not equal to root of a plus b. Okay, now let's prove this. You know, 25 plus 9 is equal to 34. So you cannot combine this as we did for multiplication. So you can only combine this when you have multiplication, then you also do multiplication inside the root. So now let's prove this. So if we solve this one, root of 25 is 5, okay, plus root of 9 is 3. So you can see that 5 plus 3 is not equal to 34. So this is 5 plus 3 is 8. So whenever you see this problem with plus in the middle, solve them differently and add the figure. Alright, then for root 10, the same thing. Root a minus root b is not same thing as root of a minus b. So in this case, this is root 25 is 5 minus root 9 is 3, and this is not equal to 4 because here is 5 minus 3 is 2, and 2 is not equal to 4. Alright guys, if you watch this video up to this moment, I want to say a big thank you for sticking around. Please like and subscribe to this channel for more interesting videos like this. Bye.